Assalamualaikum, my name is Rafatin Amira binti Zianan, my metro ID AF180150. I am from Group 3, Section 3, and the title of our group project is Kubirta La Foresta Stadium. Our group members consist of 5 members. I will present the stadium overview and project summary for this project. But before that, I will explain about the content in video presentation. We have 6 content. First one is stadium overview, second engineering judgment, third drawing layout, fourth determination and size proposed, fifth analysis from software, and the last one is condition and recommendation for this project. I will explain about the stadium overview. In this project, our group proposed a design of sports center with multiple court type stadium that will accommodate a variety of different events in a certain time. This sports center focuses on construction of football, basketball, and volleyball court. This project is located at Colombia, South America. The purpose of this design is to build this stadium will tend to increase practice level sport through the option of providing good condition and environment for the sport. The details of this project is the area is 608 meter squared, the dimension is 32 meter times 90 meter, the duration of this project is 2 years, and the project architect is James Abner Corral. Next, for the project overview, in summary, this project we are using AutoCAD to simplify layout for truss drawing, side and rear elevation, and base plan. Next, the determination of internal forces by using software analysis, which is StatPro, and also manual calculation to do the verification of critical members. For designing tension and compression truss members, it consists of top cord member, bottom cord members, inner cord member, outer cord members, diagonal cord members, and vertical cord members. The design for connection, we are only using welded connection, and we sketch the detailing of welded connection. Lastly, we propose the recommendation and conclusion for this project. That is the overview of our group projects. That's all from my part.
My name is Ahmad Kamakari. So I'm represent a type of truss that we use. So for the first one is planar truss. Planar truss members are arranged in two-dimensional plane, depending on the requirements such as end length and loading state. A number of trusses are available. So the second one, roof structure. On the outside, two crosshair arches support a wide roof framework. They are attached to two longitudinal beams that are aligned with the rectangle of the playing field. And size purpose. For the project, the proposed truss area is 31.85 meter and 21.08 meter times 8.91 meter in height. For stick grade, both beam and column we use stick grade S275. For connection type, pin connection between beam to column and pin connection between beam to main beam. For the first one is beam, we use U-beam 203 times 133 times 25. For the top and bottom cord, we use RHS 160 times 80 times 8 for member 1, member 2, and member 4. Diagonal and vertical brace member, size 160 times 80 times 6.3. And the second one is 305, 165 times 40. Type of connection, we're using welding angle. For load computation, the list below is definition for the load using the design building. Load shifting is 0.05 kN per meter cube per meter square. For purling, 0.05 kN and per meter square. For combination, we use 0.55 kN per meter square on plan. Okay. For top cord, GK is 0.55 and QK is 0.75. For bottom cord, GK is 1.0. For consider spacing of truss, distance between trusses is 3.05. Therefore, total uniform load for top cord, GK is 1.68 and QK is 0.76 and WK 2.29. For bottom cord, GK is 3.05 kN. So that's all for me. Thank you.
Assalamualaikum, my name is Siti Nur Aini binti Abu Basar. So I will explain about the design overview. So to ensure that users can carry out their duties in comfort and protection, modern stadiums should have spacious and high quality dressing room and other facilities. So this project, steel plate and aluminium plate structure will be used for the roof and skid envelope of the plan stadium. So nowadays, as we can see, all the stadium in Malaysia are used the steel component. Because of what? Because of the cost, because of the maintenance, and some of that. That's why we use the steel plate atau steel component of our structure, not brick like a house. Okay. So next, truss. Truss is a structure made up of members or elements that only take stress or compression and do not bend in any way. So only axial force occurs in the structure since the members are bound with a joint that is either bolt or welded. So for this project we are use both of bolted and welded, which is for joining the part of our structure. Either it's from the beam and column or roof of column. Some section we use bolted, but some section we use welded, and some section we use both of them. Okay, so next. So this is our truss drawing. As we can see, our column. Normally, column is only the one like straight, right? But this stadium, we use same as our truss, which is we use truss. We not use the straight of column. Okay. Next. So this is the overview from the upper. We can see the basket cut plan. This is our door to into the stadium. Okay, this is a base plan. So what is base plan? So base is the space between the trusses, which is this one truss to the other truss. So which is in this stadium there have 1, 2, 3, 4, 5 trusses. Okay. Okay, so this is the side elevation and the bottom is the rear elevation. So the side elevation, as we can see, there have a cross, right? This cross is the steel that are strained, tension to make the stability of the structure. Okay, this is a rear elevation.
Assalamualaikum and good day. My name is Muhammad Irfan Zuhaili bin Muhammad Zaid, matric number CF180130, and I'm from Group 3. Today, I would like to present my part, which is the determination and size purpose, the load computation that will be used in roof truss design and Stack Pro software analysis. For the determination and size purpose, the purpose truss area that will be used is 31.85 meter times 28.80 meter times 8.9 meter in height. For the steel grade that will be used is S275 for trusses. In this project, no steel beam or column are used in this design of truss because the support itself is a truss member. Only trusses and column based to reinforced concrete are used. The connection type that will be used in this project is welding connection. The table below shows the type, size and grade which will be used in this project. Such as top and bottom chord, we propose rectangular section 200 x 80 x 8. For the diagonal and vertical member, we propose two size, which is rectangular section 160 x 80 times 6.3 and rectangular section 305 times 155 times 40. The type of trusses is flat trusses and the type of connection is welding connection. The figure shows the results and the location of members such as M1 member for the top chord member, and the M2 member is the bottom chord member, the M3 is the inner chord member, M4 is the outer chord member, and the M5 is diagonal chord member, and M6 is vertical chord member. For the load computation that will be used in this project, there are various loads which will be used such as dead load, live load and wind load. For the dead load, which consists of roof sheeting, insulation, purlin, rafter, services, they have consist of different value, and the total permanent action is 0.55 kN per meter square on plan. For the impulse load, we assume to be used 0.75 kN per meter square, which the same with variable action on plan. These are the example of how dead load are applied on top chord truss member in Stack Pro software. The dead load applied on bottom chord truss member is shown in the Stack Pro software analysis, also with the variable load and wind load which has been applied on roof truss member. From the software analysis result, we have found that the roof truss consists of tension and compression member. It's found that the M1, M2 and M3 consists of compression member, while the M4, M5 and M6 is tension member. From the design results from software, it is found that the M1 member top chord is rectangular section 200 x 100 x 8 is a compression member with a load of 633.06 kN. And for the bottom chord member, known as M2, has been proposed to use size rectangular section 160 x 80 x 8 with a load compression of 711.50 kN. For the inner chord, we use 305 times 165 times 40 rectangular section. For a compression member, 734.96 kN. And for the M4, we will use rectangular section 200 times 100 in times 8 with a tension load of 374.14 kN. M5 and M6 member will be proposed with the same size, which is rectangular section 160 times 80 times 6.3 for diagonal and vertical chord, and each of them has the tension load of 195.90 kN and 200.92 kN. This design result will be compared and verified by using our manual calculation. The manual calculation can be seen in our report. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Anwar Faiz Muhammad Suhaimi, CF188097. And today I would like to present for conclusion and recommendation. For our conclusion, we were able to successfully propose an appropriate size for each component of the roof truss based on the axial force from the StatPro analysis using the actions on the steel structure obtained from British Standard EN 1991 and British Standard EN 1990. And by considering maximum effects, before beginning the manual computation, we used StatPro software to build and examine the Cubeta La Foresta Stadium's loads. Manual calculations were made for the roof truss, column and truss to column connection, as well as the beam to column connection, column and beam. This assignment provided us with wealth of knowledge, including how to apply what we learned in class from the beginning to the end of the work cycle. The stadium was built according to a road tree. This project also taught us how to effectively communicate and cooperate in a group situation. The project's objectives were reached because we finished all necessary pieces and computation to successfully complete this project. The loading and analysis were done with StatPro software. Purlins, top chords, bottom chords, diagonal brace members, vertical brace members, column and member connection designs were all manually computed appropriately. As a result, software and human computation show that the truss arrangement and characteristic selection are adequate. For our recommendation, first, we are using other computer software applications for stadium design and analysis. Second one, design and analysis of various steel truss stadiums, including subdivided trusses, cantilever trusses, continuous trusses, and arc trusses. That is all from me. Thank you.